So today we're talking about slope and rate of change, which again, I know this is all stuff you've seen before, okay? But make sure that you're taking notes with anything that you're not 100% sure on, so that way you have it to reference later. All right, please and thank you. All right, so does anybody know what slope actually is? What is slope? What does slope stand for? Okay, that's one way of looking at it. It's around here somewhere. Okay, so rise over run. That's one way of looking at it, right? Does anybody know, just in general, what does slope mean? Like, when I say slope, does an image pop into your head or something? Okay, what image? Okay, an incline or a decline, right? So slope is how sharp your line is pointing up or how quickly it's pointing down, right? So can anybody tell me where slope is used in the real world? It doesn't happen too much around here because we're flatlanders, but yeah.
Like a ski hill?
Okay, ski hill, right? They have different grades. Have you heard of anybody talk about gradient before? Okay, if you ever drive, like, out west where there's hills, or Pennsylvania, you'll see signs that show, like, an incline, and it'll have a percentage, okay? Like, usually the steepest gradient that you'll hit is around 10 or 12%. And basically what that means is for every 100 feet you drive forward, you're going to drop 12 feet. That doesn't sound like a lot, but is 100 feet a really far distance when you're driving 60 miles an hour? No. All right, so you got to figure 60 miles an hour means that you travel 1 hour and a minute, right? So you're traveling 100 feet pretty quick, right? Almost 100 feet a second. So if you are, or not a second, wow, a minute. So if you're going on a 12% grade, that means every minute you're dropping 12 feet in elevation. All right? Or climbing 12 feet in elevation. So that's really what slope is all about. It's just the ratio of vertical change to horizontal change. Okay, so it's set up as how much are we changing on the y versus how much are we changing on the x. So one way we represent that, I think I put it up here, yep, is delta y over delta x. Now, this is kind of more of the scientific terminology here, but just so you know, whenever you see delta, which is what the triangle is called, that just means change in, okay? Whether it's in math or any science class you have, delta stands for change in. So we're saying change in y over change in x, right? Vertical shift versus horizontal shift as we move from one point on our line to the next point on our line. Yeah. Okay. So, for slope, this is our primary slope formula, right? We use m to represent slope, okay? So, you know in math how we always assign a letter to something or a symbol. So for us, slope is always represented by m, and this is your slope formula, y2 minus y1 over x2 minus x1. So, do you guys remember how to use slope formula? Okay, how many points does it take to make a line? Well, that's what I require. What's the minimum number you need? 2, right? So we're going to have 2 points. We're going to have an x1, y1, and all the subscript means is which coordinate, right? So this is x coordinate for the first point, y coordinate for the first point. Everybody okay with what the sub's all about? So whenever you do that in math, it's just an identifier. Okay, so when we get into powers, right, some of you guys remember when we were talking about that last chapter, you were like, oh, 3, 2, and it's 3 to the second, right? We have to say to the for superscript, because if you say just like x1, right, that actually means x sub 1. Just so you guys are clear on the language, okay? Sub, SUB, yep. So there's subscript and then superscript. All right, so superscripts are your powers. Subscripts are your identifiers. So whenever you see a big statement, if you see something sub a number, that tells you that it's that coordinate but for the second point or for the first point or the fourth point or whatever. So we need 2 points in order to make a line, and we're going to label those points as x1, y1, and x2, y2. All right, and then all we have to do is match them up and plug them in. So classifying lines, right? There's a couple of different ways of classifying lines. Yeah, we need to get through this. We got 12 minutes to cover 5 slides. All right, so positive slope, negative slope, everybody good with that, right? So it's as you look at the line from left to right, is the line pointing up or down? Okay, as we move left to right, if the line points up, it's a positive. If the line points down, it's a negative. Everybody good? All right. All right, we've got horizontal lines and vertical lines. So horizontal lines have a slope of 0. So this is where you get 0 over a number. 0 over number. Everybody okay with that? Yes? No? Maybe? So that's going to create a horizontal line. Vertical lines are when the slope is undefined, which for us means that we have a number over 0, right? You cannot divide by 0. So a vertical line is considered an undefined slope, which is a 0 in the denominator. All right, everybody remember all this? Maybe, hopefully. All right, if not, write down what you need. So we're going to be asking you to identify if the line is rises, falls, is horizontal or vertical. Okay, so if the slope is positive, what's the line doing? Is it rising, falling? Is it horizontal or vertical? It's rising, right? If the slope is negative, it's falling. If the slope is 0, it's horizontal. And if the slope is undefined, vertical. Everybody all right with that? So they're just going to be asking you to calculate the slope. So a problem like this. Tell whether the line through the given points, rise, fall, is horizontal or vertical. So what you need to do is just find the slope. So our slope formula is y2 minus y1 over x2 minus x1, right? So again, what does the y sub 2 stand for? What does that mean? Okay, it's the y coordinate to which point? The second point. So y2, so second point, right? Which of these is the y coordinate? The 1. What's y sub 1 stand for? Y coordinate, first point, right? And then x2 is x coordinate, second point, minus x sub 1, negative 5. So first things first, on top, what's 1 minus 1? 0. What happens to the double negative here? It becomes what? So 3 plus 5 is, okay, what's 0 divided by 8? 0, right? So does this rise, fall? Is it horizontal or is it vertical? Horizontal. Okay, so if 0's in the numerator, it's a horizontal line. If 0's in the denominator, then it'll be a vertical line. So same thing for here, right? So I'm just going to kind of set it up. And feel free to write, to label your points, right? x1, y1, x2, y2, all right? If that'll help you, go ahead and do that, okay? So I'm going to go y2 minus y1 all over x2 minus x1. So it's 8 minus 3. 5, what happens to the double negative here? And 5 plus 1 is? Okay. So is this a positive slope, negative slope, 0 slope, or an undefined slope? Positive. So which one of these is it going to be doing? Rising.
Is this all we have to do for homework in our book? Are we going to have to graph it? So we're just
it's all just using the slope formula.
All right.
Okay, so everybody okay with identifying whether it rises, falls, whether it rises, falls, is horizontal or vertical? Okay. Parallel and perpendicular lines. This is where the last 3 years I've taught this course, people get really confused and have issues. So parallel lines are slopes that or lines that have equal slopes, right? Does that make sense? What does the word parallel mean? Parallel means they never what? They never touch, they never cross. So that means that they have to have the same exact rate of change, right? So you have two lines that are like this, right? And if they never cross, that means that they have to be growing at the exact same rate every step of the way. That's what creates that gap. So for us, we just say parallel lines have equal slopes. Everybody okay with that? All right, and what do we know about perpendicular lines? What's special about perpendicular lines?
They cross.
They cross, and what do they make when they cross? They cross at a 90. They make a perfect 90-degree angle. So what creates that is that they have to have opposite reciprocal slopes. Okay, so for here, if this slope was 3, right, for example, I know it's not, but just play along. If the slope of this line is 3, what's the slope of this line down here? 3. Because they're parallel, they have to be the same, right? So up here, if the slope of this line is, say, 5, what's the slope of this line? Opposite reciprocal. So it goes negative, And then we have to reciprocal. So what's the reciprocal of 5? 1/5. Is everybody okay with that? So reciprocal means flip the fraction, right? So this is 5 over 1. So you change the sign and then flip the fraction. Everybody all right with that idea, yes or no, with that connection? So if lines are perpendicular, their slopes are opposite reciprocal. So one positive, one negative, and you take the fractions and flip them over. Okay? So let's take a look and see if we can figure out the next part. Yeah.
So if you get 10 for the slope going across, you would automatically, it would be 10 over 1 every time?
Yes. Yeah, if you get any whole number for your slope, it's always over 1.
Right.
Because we always want to think of slope as a fraction, because it's rise over run. So you can always do that with any slope. All right, determine if the following lines are parallel, perpendicular, and neither. In order to do this, we need to find the slope of the first line and find the slope of the second line and then compare them. So this is actually kind of like a 3-step operation, okay? So first things first, line 1. Line 1. I need to find the slope. So I'm going to use my slope formula, right, which is y2 minus y1 all over x2 minus x1. Everybody see where I get those numbers from? Yes, no, maybe? Any questions on how to fill that part in? All right, so what's negative 1 minus 2? Negative 3. What happens to the double negative here? And what's 0 plus 2? Okay, so I get negative 3 over 2, right? Can that reduce at all? No, so that's fine just like that. Okay, over here, line 2, I'm going to find the slope of this line. The same way, right? y2 minus y1 all over x2 minus x1. So what happens to the double negative? And what's 3 plus 1? Okay, double negative goes positive, and that's a 6. Can this reduce at all? Yeah, 2/3. Okay, so this is the slope of my first line, and this is the slope of my second line, and now we want to compare them, right? So if the lines are parallel, what does that mean? Their slopes will be what? The same. Okay, is negative 3 halves exactly the same as 2/3? Okay, so parallel is out. What about perpendicular? If the lines are perpendicular, they're going to be what? Opposite reciprocals. So if this is a negative, we should have a positive. Is that true?
Yes.
Okay, and what's the reciprocal of 3 halves? So both pieces qualify, right? It's opposite and reciprocal, so these lines are... So these are perpendicular lines. Everybody okay with how you're going to work through that? So find the slope of the two lines. Then when you're analyzing, if they're the same, they're parallel. If not, move on to perpendicular. They have to be opposite signs and reciprocals. And if neither of these are true, then you just put neither. Everybody good? All right. So that means homework. So please get this copied down here.